Hi, and welcome to my presentation on deepfakes. I'm Matija Dujmović. I'm an enterprise developer from King ICT, and today I'll be talking about deepfakes. So before I start, I'd like to make a quick poll with the audience. How many of you have heard about deepfakes before? Okay, more than I expected. So what is a deepfake? Well, as I said in my abstract of the presentation, it's a technique for superimposing videos or images over other images or videos with the use of machine learning, thus creating a fake. That's a lot to take in one sentence. So here's a picture of a deepfake. On the left, we have Amy Adams, and on the right, we have the face of Nicolas Cage superimposed over her. So it looks very realistic. Why? Because machine learning was used behind the scenes. So what does deepfake mean? It's a combination of two words, deep learning and fake, thus deepfake. So you may be asking yourselves, what is this deep learning you speak of? Well, deep learning is a subset of machine learning that uses artificial neural networks. Now, machine learning is a very vast field, but it can be summed up as a field of study that gives computers the ability to learn without being explicitly programmed. This is a quote by Arthur Samuel. He's a pioneer of artificial intelligence. And he said that all the way back in 1959. So this isn't something new. Machine learning has been happening for over 70, 80 years. Now, we know what machine learning is, but what is this artificial neural network? Well, to understand that, we have to take a look at what artificial neural networks are. So ANN for short. An artificial neural network is an algorithmic approximation of how neural networks in our brains work. So this is a neuron. Our brains have around 100 billion of these guys, and they're working together to create a neural network. So what's happening here is you have inputs entering the neuron, they're being processed and creating outputs. Imagine a child learning numbers for the first time in their lives. They're seeing images, they don't know what they mean. They're hearing words from adults explaining what these pictures are. They're processing this, and eventually they're learning what numbers are. So our neural networks allow us to learn. That's what makes us intelligent. Now, when these neurons and neural networks in our brains were discovered and explained by scientists, by neuroscientists, a lot of mathematicians and computer scientists said, well, gee golly, this looks like some useful technology. Maybe we could incorporate this in our algorithms, and maybe we could get some good results from this. So that's exactly what they did. This is a use case for a neural network, an artificial neural network. So we're feeding a bunch of data, in this case, handwritten numbers from 0 to 9. We're feeding them to our neural network. We're telling the neural network what these numbers are through labels. And the end result is the neural network will be capable of telling us what number it has processed. So by looking at this set, this test set, we can give newly written numbers to our neural network, and it will be able to recognize what we've written down. This is the basis of handwriting recognition. So it uses neural networks behind the scenes. There are a lot of different applications for neural networks today. So OCR, forecasting weather patterns, credit card fraud detection, self-driving cars. Tesla uses a lot of neural networks. and many more applications. So you may be asking yourselves, well, what does this have to do with deepfakes? And I'm going to get to it in a while. The man in this picture is Ian Goodfellow. He is currently the leader of Apple's machine learning division. But back in 2014, he was a PhD student at the University of Montreal. And he was out having a few beers with his friends. And one of those friends had a problem. He was working on his doctoral thesis, and he needed to create realistic-looking fake images through the use of neural networks. And they got into a sort of argument. Ian said it's not possible. And at that time, he was right. But after having a few more beers, Ian got a crazy idea. What if he took one neural network and made it fight the other neural network? So that night, he came home. He opened his laptop. He programmed until the early morning hours, and he actually did it. This man created the first generative adversarial network, or GAN for short. Now, this was a revolution, and you'll see in a while why. So, I'm not going to explain again through words, I'm going to explain it through pictures. Who's a cat person here? Really? Okay. Well, I'm a cat person. So, GAN works by using two neural networks. We have the generator, the neural network that will generate fake pictures of cats. And we have the discriminator. As we've done before with the handwritten numerals, we're doing here again with pictures of cats. So these are real pictures of cats. We've fed them to a neural network called the discriminator. And the job of this network will be to discriminate what the generator has done. Now, how does this work? Well, the generator does a first attempt. It looks like nothing. The discriminator will say, wrong, failed. Now, many attempts later, we have something akin to a cat by the generator, but the discriminator still isn't satisfied because it's seen how cats look like. This maybe abstractly looks like a cat, but no. And finally, we arrive to the situation where the generator has created a realistic-looking fake picture. The discriminator says, OK, and the training of our neural network is done. This is now a neural network, again, that can generate fake pictures of cats. Now, you may not know it, but I'm pretty sure a lot of you in the audience have used the GAN, and very recently, in the last month or two. How many of you have used this app? Now I know you're joking. So everybody was using this a month or two ago. How does this work? Well, instead of looking at pictures of cats, it's looking at pictures of, let's say, old people. And when you take a picture of yourself, it's using thousands of those pictures in a trained GAN and applies the facial features of older people onto you. And you end up with a realistic-looking picture where you're old. So it's a GAN behind the scenes. Another interesting application is this website. So all of these people have been generated by a GAN. None of them exist. If you visit this website, you will get a uniquely generated picture of a person that does not exist. So this is the work of a GAN. The guy, Ian, discovered this in 2014. It's only been 5 years. 5 years ago, nobody would have believed you. This was impossible. So that's how you know it's a revolution. So let's move to the interesting part. Now you know how deepfakes work behind the scenes. So let's make a deepfake. To start, we're going to need some hardware. This is my desktop PC. I built it around 2014. At the time, it was pretty powerful, but today it's 5 years old hardware. It can basically run new games at normal settings. So nothing impressive. these are all crucial aspects of processing and training GAN, but the most important part, without a doubt, is the GPU. So in this case, I have an AMD GPU with 4 gigabytes of video RAM. This is okay, but the recommended approach is to use an NVIDIA card. Why? Because NVIDIA offers official support for deep learning networks. So you have, the manufacturer gives you a library that can optimize the use of training neural networks. AMD unfortunately doesn't have this. They're always saying they're working on it, it's going to be out soon, but it's going to take a while. So next from this, we need some software. Now, I decided to use one of the most popular frameworks for creating deepfakes. It's called Face Swap. And now that we've have the hardware and software, whose faces are we swapping? Meet Model A and Model B. What we're going to do is we're going to superimpose the face of Model B on Model A. How are we going to do that? Well, here's the process. Extract, train, and convert. These are the 3 steps we need to follow. Extraction means we need to find videos of the models. We need to extract their faces from these videos, so our neural network will have training data. So think of them as the pictures of the cats. We need a lot of their faces to make this work. So this process took me around 6 or 7 hours. It's labor intensive. You need to search for the videos, you need to remove false positives, you need to remove the faces that don't belong to your models. But Face Swap is a very good tool, and it offers a convenient extraction tool, which helps you. So here's a YouTube video of Model A. And Face Swap offers a feature where you just link the video, and you'll get an output folder with all of the photos extracted from this video. Now, of course, there are steps in between where we need to remove the false positives and faces that don't belong to Model A, but that's it. Now, we need to do this for Model A and Model B. We need to use multiple sources. One video is not enough. In my case, I used 5 videos for each of them, each video lasting 5 minutes. The end result was 30,000 faces of Model B and 30,000 faces of Model A. Now, this gets weird when you're looking at faces all of the time, but trust me, this is the easy part. Now we're at training. This is the hard part. So, when I said extraction took me 6 or 7 hours to complete, training can take anywhere between 3 days and 3 weeks, depending on your GPU. So my GPU wasn't up to the task, and it took a lot of time. Let's see how training looks inside the Face Swap app. Now, when we start training, we get only these gray blobs. So this is 0 iterations. Nothing has been trained yet. We have only the original faces, and the GAN hasn't even started doing anything. Now, already, after 1 day, we can discern faces. Now, they're blurry, and they're not yet ready, but this is after 1 day of work. Now, pay special attention to this column, A to B. So this is where our Model A is being transferred to the likeness of Model B, or the face of Model B is being transposed. So these are all images that will result in the final training of our network. So this is 1 day. What happens after 4 days? The images are less and less blurry. We're getting sharper and sharper facial features. One of the bizarre recommendations for this training step is wait until you can see individual teeth of your models. That's when you know you're done. So you can kind of see the teeth in these models. Next up, our GAN has been trained. We're over with the hard part. As you can see with the title up there, it took me more than 4 days to generate these results. Now we're up to the final step, and that's conversion. We need to choose a video that we're going to superimpose, and we need to use our GAN on the video. Now, again, FaceSwap offers a convenient tool for this. We just point to the location of our GAN, we point to the location of our video, and here's a preview of the process happening. Now, the end result This is just a random interview.
Do you not like that, or is it scary? No, you said it was not. Maybe one day, I don't know, but I don't. See, it's good for businesses. I can see that.
Yeah, it makes sense. I get it. For me personally, I'm social with the people that I
like to talk to people. People are good.
I'm worried about it.
So notice the artifact when there's a profile shot. That happens because my training data didn't include enough of the profile shots of the models. But it's still okay. So I think you got the picture. Okay, so just a bit of lessons learned on this project. Next time, I need to use a NVIDIA GPU, that's for sure. Data quality is obviously more important than data quantity. I had 30,000 images of the faces of my models, but they were ripped from 720p YouTube videos. Now, 720p is an okay source, but YouTube uses a lot of compression, so it doesn't look up to par. The recommended approach is to rip Blu-rays if you want to go for a high-quality deepfake. So you rip Blu-rays, you use different scenes where the actors are lighted differently, and you will get much better results. This already, to me, looks okay, but you can do better. And finally, you need to let the GAN train longer. I thought 7 days was okay. Maybe it's not noticeable on this screen, but it could have used a little more baking in. Some of the, So some of the resources I used to learn all this information was TensorFlow, a popular deep learning framework from Google, FaceSwap.dev, the FaceSwap forums. You can find a lot of interesting data there and past experiences of people using FaceSwap to do deepfaking. And finally, if you're interested in deep learning, there's a very good book by Manning called Grokking Deep Learning, and it's beginner friendly. So you don't need a degree in math, you don't need to know advanced statistics or stuff like that. It's a very cool written book. So that's all from me.
Are there any questions for Matija?
So yeah, I have a question. How good can the deepfake go? In the video we can see a poster of Jennifer Aniston on it. Can the deepfake recognize the image of the poster, so fake that face too, or do you have to select the frame or something?
Yes, of course. The posters in the background of the interviews were actually a bit of a problem for my process of extraction because the images from these posters were recognized as faces. So I got around 10,000 pictures from those posters alone. Yeah, all the faces are recognized. So the interviewer, the person that was in the interview with her, all of these faces were picked up by the extraction algorithm. Yeah.
What beer did the Ian drink? This guy in the first part of the presentation, the Ian. What beer was it? Before he got this brilliant idea.
It was a Canadian beer. So actually, in the story of how GANs were invented, there's a very cool interview by MIT Press on Ian, and they really go into detail. So they actually say what table they were sitting at what brewery in Montreal. So maybe we can find it out.
Can you share some useful application of this technology?
Well, aside from having a few laughs, there is a major field of use for this in CGI. So I don't have it at hand, but there's a picture from the Star Wars movie Rogue One where Princess Leia, the young Princess Leia, is shown, and her face was done through CGI, and it looks unnatural. There's a YouTube video where one user used a deepfake of young, what's her name? Carrie Fisher. Carrie Fisher. So they used photos of young Carrie Fisher to create a very realistic deepfake that they used on that scene in Rogue One, and the results are unequivocally better on the deepfake. When you take into account that that's something that somebody could have done in 2 weeks on his home computer, and the original was a result of a CGI team doing a week of intensive labor of structuring the face, doing motion capture and stuff like that, I don't know, the sky's the limit. We can only see in the future.
Great. What if in the last video there were model A and model B in the video?
Okay.
Would be able to swap their faces?
Yes, of course.
That'd be cool to see.
Yeah, I've constantly been referring to our GAN as a network that will superimpose face B on model A. But to train the GAN, we actually need to also teach the face of model A to be swapped on model B. So a byproduct of this training is that the swap can go both ways. We don't need to train the network again. We can actually do the swap from the same network.
Thank you, Matija. Our next lecture will be in 10 minutes. And please use Eventrify to give good scores to Matija.
Thank you.